Hey guys, welcome back. For quite a while, we've been working on this M8 versus Twin Cam Skunkworks build series. And all the videos we've done up to this point have been, we went through the bottom end, we went through cranks, we've talked about cam plates and oil pumps, we've talked about cylinders and pistons and headwork and all of that to get us to the point that we're actually building the engine. So this is the Twin Cam out of the 07 Ultra Classic for Dorothy and Daryl. The one we did the video on the other day with Timken bearing conversion and setup, so the case is fully assembled. In today's video, we're going to go through all the parts that are going to be used to build this engine, and we're also going to put the cam chest together. So stick with us. Before we get started, I want to kind of explain a little better what the whole Skunkworks engine program is about. Yeah, it's about that whole top secret aspect of engine building and making significant power, doing things way outside the box. But it's also about custom tailoring an engine to someone's very specific use and plan for the bike and also their budget. So it's more about designing an engine specifically for an individual, like that custom tailored suit. And that's what we've done for Dorothy and Daryl here. So a quick review, let's go take a look at the case real quick. This is a Dark Horse Crankworks crank. This is completely new, their man-of-war assembly. Of course, we did the Timken bearing conversion. It has the H-beam rods. It's been balanced, trued, plugged, and welded. We have less than 1/2 of a thousandths pinion runout and less than 7/10 of a thousandths runout on the sprocket shaft. So this crank is spot on and perfect. And we had also set the end play at 2.5 thousandths. So we've got a rock solid bottom end ready to go there. For the cam chest, we're going to go with an S&S cam plate pump, tappets. We're going to use the Torrington inner cam bearings, of course, and we are going gear drive because we've got a perfect crank. We're also going to use the S&S push rods. For cam choice, I've decided to go with a 570 in this one. It's perfect for how they ride. Okay, this engine's going to be built to about a 10-to-1 compression ratio, and that cam is perfect for their two-up riding in the North Georgia mountains and fuel availability and things like that we have here in the South. This engine should produce somewhere with the exhaust that he has, somewhere in the ballpark of about 110 horsepower and 120 foot-pounds of torque with a very broad torque curve coming in early. It's exactly what they need. For pistons, we're using our pistons. They have the abradable skirt coating on them, and they also have a hard anodized crown. And you'll notice that anodizing actually hits the top ring as well to prevent any separation and keep a good tight fit on the upper compression ring there. And so these are our design, and KB makes them for us. Be using those. The heads, I'm not completely done with the heads yet, but I'll show you how we're progressing. Of course, we've started on the chamber polishing here. We haven't done the valve seats or anything like that. We have put the guides in it, and we have finished up the porting work. There'll be a little more touch-up done here once we do the valve job, but the heads are in progress. The cylinders. These are his stock cylinders that we have bored to a 3937 bore. Got a perfect finish there, and this cylinder is to within a 1/10 of a thousandths top to bottom across all axes. Cylinders perfectly straight. Now, it's one of the other ideas with this build is for this to be the last time they have to do this to this bike. You know, they want to enjoy it for a long time. So we wanted to address all of the other common and kind of known issues in the 07 year models aside from the engine, and one of those was charging system. So we're going to be upgrading his charging system to one from Cycle Electric. They make incredible charging systems, and actually in all the years that I have been using Cycle Electric's stators and regulators, if you guys, any of you have been in the business for a long time, I'm sure you'll agree, and near 20 years I've been using their stuff. I've never had a single defective part. That's an awesome thing. So that will address the charging system with the stator and regulator. Then we move into the primary. We'll be, because his is an 07, he has the integrated spring pack on his stock rotor. So we're replacing this with a later model rotor. Then we'll be using a man-of-war motor sprocket, 34 tooth count. It's going to be perfect for them. We're going to be upgrading to a Trask billet clutch basket. We'll also be using a Baker primary chain adjuster. Then we'll be using an American Prime Comp Master clutch. Fantastic clutch. They also, again, they occasionally will get caught in traffic and things like that. So we're going to go with a Jag fan-assisted oil cooler. In this type of build, a very basic air cleaner, you don't need anything fancy. You don't need anything expensive. The Arlen Ness Big Sucker is a great choice. It moves an adequate amount of air and will make great power on the stock throttle body that we're using in this one. So that's what we're going with for the air cleaner. We are going to upgrade the injectors. On this one, we're going to go with a 5 gram per second injector, and they've been fully blueprinted and flow matched, so we know we're good there. As far as suspension goes, of course, we're going to go with the Legends rear shocks and then with the Legends fork cartridge, and that will round this bike out. And of course, before we give it back to them, we're going to go through the other systems on the bike. We're going to check the brake system. We're going to, you know, flush and fill and do all that type of stuff. So this is to a large degree kind of a mechanical restoration on the bike. So that completes the build. So now let's get started and put this cam chest together. A couple things I'd like to cover. Check out the new shirts. All right, so what we're doing is once a month, I'm designing retro logos. And for those of you that might be able to tell, this is actually a take on an old Champion spark plug logo. So if you would like to support the channel either through membership, or you can also order merchandise. If you click the link in the description below, it'll take you to our Teespring store. And once a month, we're going to be putting up new designs. And again, kind of cool retro hot rod type stuff. So check it out there. The other thing, I want to give a big thanks to the folks at Jim's. This has got to be the coolest engine stand I think I have ever seen. So it rotates, which is great to work on both sides, and it also tilts, which you'll see is how useful this is during the build. So loading pistons and cylinders can be kind of tough on a worktop, so it makes it real easy here to have direct access to it in that direction. Sometimes putting a cam chest together for the gear rotors on the pump, you can tilt it this way and everything falls right into place. It makes everything great to work with. Of course, Jim's makes all kinds of stuff. If you've never checked them out, check them out at Jim's USA. They make tools, they make performance parts, and before long, we're going to be talking with Denise from Jim's, actually, and we're going to talk about adjusting hydrosolid lifters and all the other products that they have and tools and performance equipment. Their 5-speed transmission, which is awesome, and all that type of stuff. So look for Jim's to be on the show very soon. All right, guys, here we go. Cam bearing install tool. Install a little bit of press fit lube on the outside of the bearing. I always like to install them with the riding out. I'm not sure if that makes a difference or not, really. That's just the way I've always done it. Of course, on this case, we've already chased all the threads and made sure they're good. All the old Loctite is out of there. All right, with any type of cast then machined part, you always have a little bit of what's called core shift. All right, so I don't like to lock this plate all the way down. I'll seat it and then back the bolts out just a little bit and let that plate float a little and let the bearing kind of self-center in the hole. I have seen people just go ahead and cram that bearing in there without taking this little extra precaution, and it'll actually deform the bearing slightly. So let's leave that a little loose. That's enough. We can walk this in here slowly. And once we kind of wiggle it around a little bit and let the bearing center itself. Once you can get it hand tight, then you can go ahead and do about a quarter turn here to tighten these down so the plate doesn't move. First, you want to go real slow. It should feel smooth all the way through the rotation. There we go. And once you feel it seat, you don't have to go extremely tight. You know, the tool is going to set the depth of the bearing, so you just want to kind of snug it just to make sure it's all the way down. You don't have to wrench down on it too tight. Like I said, I'll seat these all the way, then back them off about 1/4 of a turn, just to give us a little bit of float. Again, we're going to go real slow, and you shouldn't feel any sort of bind. It should be a consistent pressure all the way through. You notice I put a rag on the pinion shaft there just in case. We don't want to scar that. There we go. You notice another thing, I always use microfibers when I'm assembling an engine. They're lint free. Don't leave lint behind. Great deal. Now let's have a look at our bearings. And you want to feel the rollers, make sure they're not binding. They should move very easily and be very smooth. If not, then you may have crushed the bearing race a little bit when you pressed it in there. Also, feel around, make sure that they're equal depth and just below the surface of the case. While I'm at this point, I like to go ahead and put some assembly lube on those bearings. Roll it around a little bit. I'm going to go ahead and put my O-rings on the case. I also like to use assembly lube on these, mainly because assembly lube's a little bit sticky and more likely to stay in place. Now you may see varying opinions on this as far as the O-ring for your oil pump. I don't put it in the case first. I put it on the oil pump. And the reason I do that is because once you get the pump in place, it's very difficult to see the ring. And there's a possibility that when you put that ring in here that you can catch just the edge of that O-ring and it actually fold and bend inside the case. So what I like to do is put the O-ring on the pump, then put the pump into place. Now let's pull the pump apart and inspect it. One of the first things you'll notice on your inner gear rotor, I've seen people actually make this mistake. On the innermost one, you'll notice that there's a bit of an offset here on the flat. All right, that offset always goes toward the engine case. And the reason for that is to have enough clearance for that area right there of the crank. So always make sure that that notch is pointing inward. And let's say a little bit of assembly lube. I always like to install the O-ring here first, and then press it into the case from there. Of course, before you do this, you would normally always check crank run out. But guys, I have done several videos on checking crank run out, how to check it, and there's plenty of videos out there. I already know what the run out is on this one, so we did that when I assembled the case. I'm gonna walk that O-ring in there real easy. See how it pops right in? Now we have no fear of that O-ring rolling inside the case. I'm also going to look down there just to try to get a visual, make sure it hadn't pushed out. We're seated, we're good. Inspect our gear rotors, everything's clean. The other thing you always want to look for when you do this is, often there's machining, oils and lubricants and things like that on a lot of these parts. So you always want to make sure everything's clean, and if you notice those oils or films or anything like that, you want to be sure to brake clean all of those items. Make sure it's clean, but these are clean and in great shape. Gear, don't force it. Everything should slide together. If you have to force it, then there's a problem. And again, remember that flat has to go toward the case. One thing you want to check, run a straight edge across the gear rotors and across the engine case. The gear rotor should not be protruding beyond the engine case. It's just a way to double check yourself and make sure that everything is seated fully. I always like to remove some of the assembly lube from the outside. I know it'll squeeze out, but I'd rather just have that mating surface nice and smooth there. Obviously, cam timing is critically important, guys. So bounce a teeth. Sometimes it can be hard to tell if a tooth is exactly the right tooth. So when you're one tooth off, it is obvious that they don't line up. So I always like to bounce back and forth from one tooth to the other. And it doesn't hurt to double check. Yep, in good shape.
Yes, I'm pretty sure that you literally have got the last one. What year's your bike? You probably have got the last. You probably got the last one.
Of course, I've already blown this cam plate out, checked it just to make sure everything is nice and clean. You also want to feel for any burrs around these to make sure it's not going to be lifted up. And I actually like to the flattest side to put it down. There's a bit of a bevel on that edge there. Just make sure there's no burrs that would hold it off and keep it from sealing. Sometimes you have to give it a little tap. There we go. Does it snap into place? Not a bad idea just to make sure it's seated all the way. A little more assembly lube on our pinion shaft here. Verify that our O-rings are in place. We're good to go. Verify our cam timing. And up here for the lifter galleys, again, clean, 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 clean. And again, guys, don't force it. You know, that bearing or this bushing down here on the pinion shaft, you know, make sure there's no burrs, of course, which we'd already done that, but don't force anything. Just let it slide on in and you'll see that that's exactly what it did. Just slide right into place. And you can also verify too, you should have a little bit of a gap on this side here, just again, to make sure that your O-rings are still seated and there's no issues there. Again, you don't need too much Loctite. My kind of rule of thumb is if it's a 1/4 inch bolt, I go about 1/4 of an inch up on the threads, let it saturate them, and then just knock off the excess. Now I don't seat these all the way down. I'm just kind of getting them started right now. Now back in the day on the twin cams, you had oil pump alignment pins, and some people still use those, but I found another different little way of doing it that I'll show you here. What I want to do is rotate this over the assembly. I want to feel it, make sure there's no binding, nothing feels odd. Perfect. All right, now I like to switch over to a screwdriver. I'll seat it and back it off just a hair. Seat it and back it off a hair. Get off just a hair. Just enough that you can feel that the bolts are still loose. And let's rotate the crank again. What we're doing is letting those gear rotors find their natural center and going in a little at a time. Okay, I'm going to go just a little tighter. Again, just with very little resistance. You can see I'm only using 2 fingers. The idea is, again, to let those gear rotors and that pump find its natural center. And you'll feel more resistance at this point. I mean, this crank will, butter smooth, but with all the assembly lube that we have in there, and then now the pump is tighter, you'll feel a little bit more resistance than what you did when you first started. So don't let that send you into a panic. Excellent. by hand. I'm going to turn it one more time. Perfect. I like to do this in a couple of different rounds. Now, let's move to the gear drive and we'll check our backlash. Let's get our keyway in there. Sometimes you got to give it a little tap to make sure it's seated all the way. Make things a little easier, we'll put a little bit of assembly lube, press fit lube, excuse me, on our gears. Also, so S&S uses the same gear for M8 twin cam, so be careful here. As you can see, out for M8, out for twin cam. Make sure you're square, make sure your keyway is in place. What I like to do is get that started. Don't go all the way in. And you want to do the same thing with your crank gear here. And the idea is just to get it started. Make sure you're timed correctly. Got a little bit there. We're probably about a 1/2 thousandths there. And about a 1/2 thousandths there. Let's put a gauge on it, see where we're at. It's about 3/4 thou. So between 1/2 and 1 there. Let's rotate it around. 1/2 thousandths there. Let's rotate it around. Another 90 degrees. Three-quarter thou. And we have 3/4 thou there. Let's measure one more time. Go through one. And we're at 3/4 thousandths. We are between a 1/2 and 1 thou. Perfect. So we're going to use red Loctite on these. Man, I love this engine stand. This thing is awesome. Thanks again, Jims. This thing is just killer. They're 25 foot-pounds, 35 foot-pounds. Excellent. We're basically 3/4 of a thousandths all the way around. We're well within our 1/2 to 1. So this gear drive should be nice, quiet, perfect, and especially having less than a thousandths run out on the pinion shaft. This is spot on perfect. Spot on perfect. I also want to look at the side here, just kind of check gear alignment, make sure everything looks great. We've torqued it down twice, so we know the gears are seated all the way. Now we can put our assembly lube. I always like to run it through a couple times just to see how it feels. Listen for any noises, clicks, or anything like that. Got a little assembly lube right there. Perfect. Okay, now let's talk about tappets and the tappet bores. Now, of course, I had already, one thing that's largely forgotten is when doing builds is the tappet to bore clearance inside here. You know, this isn't like Evos anymore. You can't just replace tappet blocks. All right, so these holes can get larger. This is actually the source of a lot of noise coming from a twin cam, is that bore, the bore to lifter clearance itself. Now, of course, that would be if that measurement was off. That's important for me to check that before I assemble the case in the event that I have to do some machining or run an oversized lifter, or possibly even hone these bores out. Now, I measured these, and oddly enough, they're exactly at the proper dimension. But even still, I had this front one right here that was about 1/10 of a thousandths smaller than the other three. So this is a very good practice. Another thing I'm going to show you once they're installed is the clearance between the lifter and the roll pin. Now, of course, I've already checked that, and I have found that that clearance there is as it should be, so I don't need to run an oversized guide pin in here to keep the lifters straight. Sweet tea. Now let's measure these up and see what we find. That one is on 842 on the money, 842. This one is just shy of. It's about 841 and a half. That's 842 on the money. Now just a little shy of 842. So I'm going to put that one there. That's 842. Just shy of. Those two are virtually identical. Let's measure this one more time. That one is slightly less. So I'll put that one there. And this one is at 841 and a half. Okay, so that means after measuring these, I remember this hole right here was just under a 1/2 thou smaller than the rest of the holes. So naturally we're going to put the smallest lifter in that hole there. Yes. So we know that's our odd man out. Okay. There's several ways you can do this. I actually used to take when lifters were really good, you almost couldn't pump oil into the port here. So I would actually take a 5/8 heater hose, put it around the edge of the lifter, and I had it hooked up to a vacuum pump, a Mighty Vac, and would suck the oil into it. But what I found over the years, and I've actually massaged, you can see the tip of this, that I've hand filed the tip down on this to where it fits inside that pocket almost perfectly and allows me to pump oil into the lifter, and you'll start to see the air bubbles. So we're priming that lifter. Another thing I like to do is put a little bit of assembly lube and work it into place. And got our lifter full. Now you'll often hear there's often some debate on where the hole should go, the feed hole for the lifter. And when I look down inside the bore, truth of it is it really doesn't matter. But because the oil is going to be around this entire area of the lifter and come in here, and it really just doesn't matter. But what I like to do is actually point them toward the center. Some lube in our rollers. You can see the air bubbles coming out there. There we go. All right. Well, there we go. That's the cam chest done. In the next video, we're going to load pistons, cylinders, bolt the heads on. Before I sign off, guys, I want to say a couple of things. First off, a big thanks to Jim. This is the first time I've built an engine on this particular stand, and I got to tell you, man, this thing is absolutely awesome. So big thanks to Jim for what they do, not just the performance parts they make, but things like, you know, their tools, their precision tools, and they take a beating and they last a long time. So thanks to the crew at Jim's for making great tools to help us earn a living. For the past couple of days, I've been pulling my hair out. My valve seat and guide machine decided to go on me at the right in the middle of doing a set of heads, which is the reason why I don't have the heads done for this yet. However, if you guys have never heard of John Cassie, John Cassie has a 50-plus year pedigree in the automotive engine machine world, and he has done some absolutely incredible things over that period of time. Just so happens, John's shop is 2 shops down from mine. We kind of on a horsepower row, if you will, here. So the part that failed in my valve seat and guide machine is this pneumatic cylinder. It controls the locking mechanism that holds the head that contains the cutter to cut the valve seats and guides and do things like that and do all your valve jobs. Without this, you can't lock the head down. There's an O-ring on the inside of it that failed, and I have been searching all over the US and Canada to try to find a very specific cup seal to fit this, and it basically doesn't exist anymore. So I called my buddy John Cassie, and he tasked one of his employees with finding me that seal, and it's just absolutely awesome. You know, guys, and you know, it's horsepower industry, you know, we all stick together, whether it's cars or motorcycles or whatever the case, you know, it is. You know, we try to help each other out, and so I want to say a big, huge thanks to John. And we got the seal this afternoon. He brought it to me so I can get the valve seat and guide machine back up and going, finish these heads, and we can continue on with this series. One other big, huge announcement. We just crossed the 20,000 subscriber mark, and you guys are just absolutely awesome. You know, your likes, your shares, your comments. I love reading it. I love this community that we're building here. So again, thanks a million for your support and for following along. If you're interested, keep an eye on our Teespring store for the shirts. Again, we'll be releasing a design for that once a month, vintage throwbacks with the Skunkworks logo. Thanks a million, guys. Take care of yourselves and each other. Have a good one.